All right, we're done with significant figures. So that's kind of the hugest part of Unit 1. Now there's just three more things we're going to do, being the metric system, solving formulas for a specified variable, and I'm drawing a blank. Oh, graphing. So the next thing we're moving on to is the metric system. We are Canadian, so we are only going to deal with the metric system. In fact, I'm not even going to make you convert from the imperial because none of the questions that we do will be in imperial. They will all be in metric. So when converting units within the metric system, there's two main methods. There's others, but there's two main that we're going to look at. The first ones we call really, technical, the sliding scale. So what it is that we've got this lovely data package that you were given. And in it, there's a chart that shows all of the prefixes within the matrix system. In fact, actually, let me make this large. So the metric system is really cool. And I actually didn't know this, and I'm not ashamed to admit it when I first started, is that the metric system is all based on units of powers of 10. So for example, you can have a base unit of a meter or a liter or a gram or a second or a byte or anything along those lines. And then when you put a prefix on it, it's known kind of where you are within the metric system. And the reason we have prefixes is that you can have a really tiny portion of a meter. And so instead of saying you have 0.000000006 of a meter, you'd say, hey, you've got a nanometer or something like that. So the way the system works is that the tenth of a meter is called a decimeter or liter or gram or seconds. I'll just keep using meter for this purpose, but it's a decimeter. And then 100th of a meter would be a centimeter. 1,000th of a meter would be a millimeter. Then there's these two blanks that I actually don't even know what the prefixes are. Someday I'll look them up. But generally we kind of jump from milli to micro. So a millionth of a meter is a micrometer. I feel like I'm going to get this wrong. Millionth and then a billionth, is that right? Is a nanometer, and then a trillionth would be a picometer. Anyway, what it is that this would be a very tiny portion of a meter, but they're all powers of 10. So if you go the other way, we go that there are 10 meters in a decameter. There are 100 meters in a hectometer. There's 1,000 meters in a kilometer. And then we go 1,000,000 meters in a megameter, which doesn't make much sense. Let's go towards gigabytes, right? So you have a million bytes in a megabyte. You'd have what am I at? 1,000 million trillion? Is that how that works? A trillion bytes in a gigabyte and a billion? I don't know. Anyway, I shouldn't even talk. There are 10 to the 12 bytes in a terabyte is all you really need to know. So, when you think about memory storage, we had to go quite bigger, right? That's why we've got these prefixes. I'm sure there's something beyond the terabyte that we'll care about pretty soon for computers. And then if you go really small, we go down to the pico and maybe even smaller past there. But the way the sliding scale works is this. What you're going to do is you're going to be at a number like 5.74 centigrams. So we are here. We are at 5.74 centigrams. If I wanted to go to the grams, I have to go to the left two spaces. So to do the same thing with your decimal, you go left two spaces and you'd put in a 0. So 5.74 centigrams is 0.0574 grams. Because the metric system's powers of 10, it's simply moving your decimal place either to the left or to the right, depending upon whether you're making your number smaller or bigger. So let's get you to try this one. If we're at 264 nanobytes and I wanted to get to grams, and I wanted to get to grams, how many places do I have to move my decimal place? Well, first off, my decimal place is here, and I'm moving it 1, 2, 3, 4, 5, 6, 7, 8, 9 places. In other words, I would have 6 zeros and 264. Okay. Sliding scale also works the other way. If you're moving from a bigger to a smaller number, let me just erase some of this stuff. So if I was going to, actually, I guess that's not really going to get in my way. Oh no, it is. I'm going to milli. If I was going to go from a bigger to a smaller, where do I start? Well, if I'm at kilograms and I want to go to megagrams, I'm here at kila, and I need to make it here to mega. How many spaces? 1, 2, 3, 4, 5, 6. So I would literally take this decimal and I would move it 6 places to the right because I moved to the right on my scale. So I've moved 2 and then I need 4 more. So 1.41 kilograms is, oh dear, 1,410,000 milligrams. Okay, you try. Go from kilograms to decigrams this time. So 1, 2, 3, 4 places. 1, 2, 3, 4. Sliding scale, like I kind of like it. But I kind of find it annoying in the same way too. So this might not be your method of choice. It's entirely up to you. Let me just check that. So 1, 2, 3, 4. 1, 2, 3, 4. Okay, perfect. Awesome. Okay, so that's sliding scale. So just understanding that the metric system has the prefixes and everything is powers of 10, and knowing that you can kind of just move left to right. So that's option number 1. Option number 2, we're going to use dimensional analysis. This is something that is used in chemistry a ton. So if you're taking chemistry, this will probably be your method of choice. And to be honest, some people have a third method where they're kind of doing dimensional analysis without knowing it. So if you are a third method person, just know you're actually doing dimensional analysis. You're just not giving it that name and not showing all of your work. The way that dimensional analysis works is that you have to have a known conversion. Something like 1 meter is 100 centimeters, or 1 centimeter is 0.001 of a meter. So you have this known conversion that you can then analyze your dimensions to get the dimensions you want. So for example, if I have a measurement like 15 meters and I want to convert this to centimeters, I want to get rid of meters, so I put meters on the bottom. No matter which conversion I use, the meters goes on the bottom, and then the centimeters, what I want, goes on the top. And the reason that is because now you can see I put the cross through it. Meters are gone and I'd be left in centimeters. And then I get to just put in my conversion. So if it's 1 meter is 100 centimeters, because the 100's on top, I'm going to be doing 1.5 times 100 to get 150 centimeters, maintaining my sig figs when multiplying. For this one, because it's 1 centimeter is 0.001 of a meter, I'd be plugging it in as 1.5 divided by 0.001, which would also give me 150 centimeters. If you're wondering where I got this conversion from, this is if you're using this chart. So most people use this. They're like, I know that a meter is 100 centimeters. But if you're using this chart, what happens is that this is always what goes with the meter, right? Or the base unit, I should say. So 0.01 meters is 1 decimeter. 0.000001 meters is 1 micrometer. Same thing here. 1,000 meters is 1 kilometer. 1 million megameters is 1 meter. Okay, so if you want to use your slidey chart, these numbers are what can give you your conversion, but you're more than welcome to also just use baseline knowledge to say that 1 meter is 100 centimeters instead of trying to use this chart, which can sometimes be confusing. So if I wanted to go from grams to kilograms, I write first off what I have. Let's do it with the steps here. I skipped them. Step number 1, start with what you were given. Write it down with units, 73,000 grams. Step number 2, choose an appropriate conversion. Make sure to cancel out the unwanted unit. So if I'm in grams, I want to get rid of grams. They go on the bottom. And what I want is kilograms. Then I have to find a conversion. I know that 1 kilogram is 1,000 grams, and that's also what my data package would tell me, right? So if you look over here, right, 1,000 grams is 1 kilogram. So what am I typing in my calculator? Well, 73,000 times 1 divided by 1,000. You don't need to write times 1 because it won't do anything. So I'm just going to do 73,000 divided by 1,000, which will give me 73 kilograms, maintaining significant figures. All right, what about microliters to decaliters? So this one, I actually do need, I need that formula sheet beside me because I don't know all of them. Okay, so for this one, this is actually going to be a two-stepper. This is one of those ones where I might actually even use the the slidey scale. But what I would do for this one with a dimensional analysis is first off, write off what I want, or what I have, sorry. And then I need my conversion. Now for me, I'm going to go from microliters. I can't go all the way to decaliters maybe to start. I might go to liters to start, and then I'll do this as a two-step conversion where I now go from liters into my decaliters. Okay, so the capital D means deca. Some people will use a DK, and then the little d means deci. So we're going from micro all the way to deca, and so I'm going to do this as a two-stepper. So my first one is that I know that this one up here is what goes with my liters. So 1 microliter is equal to, now you can either write 0.000001 or times 10 to the negative 6 liters. And then same thing here, I know that 10 liters is 1 deciliter. So again, what goes with your base unit is the number written up here. And what this will do from a dimensions point of view is that I will cancel out micro with micro, liter with liter, and I will be left with deciliter. How do I plug this into my calculator? Well, I plug in 5 times 10 to the negative 6, so 10 to the negative 6, or you could do 5.6 times 10 to the negative 6, and then divided by 10, which gave me a gross decimal that I'm going to write as 5.6 times 10 to the negative, it should be 7. 1, 2, 3, 4, 5, 6, 7 decaliters. Now, when I was plugging that in, I was like, you know what, somebody might actually struggle with that. So let me just show you how I plugged it in on this guy. So if I plug this one in, I plugged it in as 5.6 times, now I wrote 10 to the. Now my to the is a y to the x button. Some people might actually have a button that has just this cap on it, but that's how you do an exponent. And then I'm going to put negative, whoops, I didn't like that, times 10 to the negative 6. And then I typed divided by 10. Right? And that gave me 5.6 times 10 to the negative 7 on this calculator. My calculator gave me 0.000, blah, 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 blah. Okay, so there's 2. Why don't you give these 2 a try? Or if you're not confident, I can do it with you. And again, if you hate this dimensional analysis, I don't care if you do slidey scale. On the test, it's not going to say convert using the slidey scale, convert using dimensional analysis. It'll just say convert. So as long as you get it right, you're fine. And it is a lot easier when they just go to the base unit. I threw in a couple where they go beyond the base unit just to see how you would do. Okay, so for this one, I'm in nanograms. I want to get rid of nanograms and I want grams. I'm going to go back to that formula sheet because I do not have these memorized. And I see that nano is 10 to the negative 9. So the 10 to the negative 9 is going to go with the grams, and that is 1 nanogram. So then to plug this into my calculator, I'm going to do 264 times 10 to the negative 9. Now, my calculator gave it to me as a decimal, so yours might go scientific notation, but I'm going to put it as 2.64 times 10 to the 1, 2, 3, 4, 5, 6, 7 grams, right? Because this is times 10 to the 2. Anyway, I won't go into that, but this makes sense, okay? You could have also done 1 gram is I don't know if I know my powers of 10, billionth of a gram, whatever it is. So you could put 1 over however many zeros that would be. All right, next one. I'm in 8.2 kilograms. I want to convert to decagrams. So the first thing I'm going to do is go kilograms into grams. Then I'm going to go grams into decigrams. I know that the conversion is that 1 kilogram is 1,000 grams. And then this conversion here, if you go back to your formula sheet, deci is 0.1. So I'm going to put 0.1 to 1. Okay, remember that number that's on the formula sheet is always what goes with the grams. Some people also just, would maybe times by 1,000 to convert from grams and then divide, or times by 10 to go another level over. The process isn't important. It's the fact that you can convert. And to be honest, Most of the stuff we're going to be converting is kilometers into meters. This other stuff is just a bit of like a, hey, could you? Sure, great. Okay, so 85,000 decigrams.